Remarkably, these granite blocks were shaped by hand, without machines or metal tools.
I'm looking at a big piece of granite here, and we're going to try a demonstration of how we think the Inca were able to shape these rocks. But you can see that I'm beginning to fracture off pieces. Granite, of course, consists largely of crystals of quartz, mica, and feldspar, and those fracture fairly easily.
Almost 10 times stronger than concrete and fractures easily, making it ideal for building. The Incas sculpted the blocks by hand so that they would fit tightly together. There's no cement to glue them in place. So how do these walls stay standing in a country hit by more than 100 earthquakes a year? In 1950, a huge earthquake rocked Cusco, devastating over half the city. The Spanish colonial walls came crashing down, but the Inca stonework survived.
It represents the finest of Inca construction and stonework. In fact, the joints are so tight that it's impossible to put a knife blade or a razor blade between.
Quake, huge friction between their perfect surfaces stops them from slipping. This design has kept the Inca walls intact through 500 years of earthquakes. Their stones fit together perfectly. But the mountaintop location gives the buildings added protection against tremors. The granite below the city plunges deep into the Earth's crust. This deeply rooted bedrock remains steady as the surrounding ground shakes. It can deflect shock waves away from the city, helping the buildings to ride out the quake and remain intact. David Aris Mendez is building a 7-story tower, and earthquake protection is a key part of the design. The huge cylinders act as shock absorbers for the building. Each one is made of layers of rubber and lead. In an earthquake, both of these materials can flex before returning to their original shape, absorbing the force of the quake. These isolators should keep the tower as safe as the walls of Machu Picchu. How did they stop their city from being washed away? Above Machu Picchu, the Incas discovered a natural spring that flowed year-round. The Inca engineers directed it into a channel more than 700 meters long. They built the canal at an angle so that gravity could feed 47,000 gallons of water every day down through the city and into 16 fountains, quenching the thirst of the city's 1,000 inhabitants. To move water away from vulnerable homes. Below the ancient city, modern engineers are harnessing Machu Picchu's intense rainfall to generate hydroelectric power. As with the Incas' channels and fountains, gravity is the key. New plant from floods, Mario and Andy are building it in a sealed bunker, 60 meters below ground. But this far down, the water cannot flow straight back into the river, so the team are digging 2 new tunnels. These can channel 16,000 gallons of water a second to an outlet 3 kilometers away, where the river is lower. The underground plant is sealed, watertight.
In the event of a flood, we shut down these gates, so all that water is diverted then into the Obamba River.
The Machu Picchu mountain power plant is one part of a network that feeds clean, renewable electricity to modern-day Peru. There are 23 hydroelectric plants across the Andes. They generate over 70% of the country's electricity, powering the homes of more than 22 million people. Like Peru's modern-day engineers, the Incas knew how to harness the power of water while keeping the city safe from floods. The engineers was how to transport goods over some of the steepest peaks on the planet without any wheeled vehicles. Their secret lies beneath the layer of soil in a layer of flat granite stones. They allow the water to run off the road to avoid the formation of slippery puddles. Granite walls support the road to prevent erosion and hold the slope in place. First, the steep cliffs, they built staircases into the mountainside. Linking together more than 40,000 kilometers of roads to form one of the most advanced highway networks in the world. A distance of over 550 kilometers was all covered on foot. Inca built some of the world's first suspension bridges. Every year since Inca times, locals rebuild the bridge using the only available material, grass.
They bring it from the up of the mountains, 4,000 meters high. We're weaving the first ropes. Without any nut, it will continue. She's an expert. No iron, no cement, just exactly like the Incas taught them.
Largest suspension bridge.
Engenharia com los puentes colgantes que los incas hacían en los Andes. Eles utilizavam o mesmo princípio, onde todas as cargas que são generadas por el vano são distribuídas no extremo esquerdo e no extremo direito.
The weight of the traffic is transferred by thick steel cables to concrete anchors on the banks, making this bridge 3,000 times stronger than the ancient Inca design. And since it opened, Peru has been able to increase exports to Brazil by 500%. Legacy is helping today's engineers build bigger, stronger bridges and better roads. Mountainside to feed the 1,000 people who lived here was impossible. Climbing on some of the steepest slopes in the world is a formidable challenge. But the Inca took this all in their stride, with terraces. Machu Picchu is built into hills that have gradients of up to 70%. To grow crops here, Inca engineers constructed flat terraces made of granite rock. A thick layer of gravel, topped with sand and soil, allowed rainwater to drain away. This gave them enough space to grow 4 tons of corn and 170 tons of potatoes every year. Engineers built vast terraces into the hillside to hold the mountain in place and provide space for crops. Also found ways of using the landscape to produce another valuable commodity: salt. Concentration of salt.
Water runs out of the spring, and there's a very sophisticated system of channels that run to various places. Once the water evaporates, we have almost pure salt.
By making the most of their natural resources, the Inca kept Machu Picchu's 1,000-strong workforce fed and watered. Most of the country's flatland is arid desert, where it's impossible to grow crops. They just need to build a dam 40 meters high across the middle of the river. This creates a huge reservoir. The water is then channeled into a 5-meter-wide tunnel dug more than 1.5 kilometers below the Andes. It's the second deepest tunnel in the world. The force of the falling water will turn 2 huge turbines, generating 4,000 gigawatts of power. When the water reaches the desert, it will travel through a network of pipes to irrigate 110,000 acres of dry land. The mountain city of Machu Picchu isn't entirely safe from the Andes' greatest threat: landslides. During the wet season, torrential rain falls on the mountains. It saturates the soil, which becomes unstable on the steep slopes. The smallest earth tremor can then trigger a landslide, causing tons of rock and mud to thunder down the mountain at speeds of more than 150 kilometers per hour. The threat of landslides remains.
Once in a while, tension cracks start to appear in the upper parts, and then the problem begins because water fills those.
Now researchers are discovering that erosion far below the ancient city may pose a threat. Mountain, flattening homes and severing train lines. Fernando Astete is the site director responsible for the safety of the 2,500 people visiting the city every day. Fernando's team have drilled hundreds of tiny metal markers into stones throughout Machu Picchu.
Se hace estas medidas para ver si hay movimiento de los bloques.
To grow their food also stops their mighty granite buildings from sliding down the slope. Terraces. These giant steps act as mountain stabilizers. Their design is a work of precision engineering. The outer edge of each terrace is formed from a 1.2-meter high wall of granite. Behind this, the Inca placed loose gravel with layers of sand and soil on top. The walls are built at an angle of precisely 5 degrees, compacting the soil and rocks and keeping these steep peaks safe from landslides. Steel cages, called gabions, are filled with rocks to reinforce the hillsides. This modern version of Inca engineering will hopefully ensure that these cliffs stay standing for as long as Machu Picchu. Machu Picchu is a miracle of engineering. The ancient people who built this mountain city were years ahead of their time. Building structures that can survive earthquakes, landslides, and floods. And today's engineers are still borrowing their ingenious ideas to help safeguard modern Peru against whatever the Andes can throw at it.